Video, we're going to go over the review sheet for test one of the spring semester. So let's take a look at question number one. So it says in triangle ABC below, DE is drawn so that D and E are on AB and AC respectively. Notice it does not say anything about midpoints or midsegments. DE is not a midsegment. If DE is parallel to BC, which equation will always be true? So the first thing I want you guys to keep in mind is since we have this segment parallel to this one, we do know that if we have a segment in a triangle that's parallel to the base, it forms a triangle similar to the original triangle. So we do know that small triangle and big triangle are similar here. If you didn't remember that theorem that we talked about in class, we do also have congruent corresponding angles and congruent shared angle by the reflexive property. So we do also know the triangles are similar by AA. So now that we know the triangles are similar, we're all set to take a look at the proportions involving the corresponding sides of the similar triangles. And when we take a look at these proportions, we want to make sure that these proportions are consistent, meaning that the way that they're set up on the left-hand side is also the way that they're set up on the right-hand side. And we also want to make sure that they do correctly put the corresponding parts from the small and big triangles together. So we'll take a look at what I mean. So in choice number one, AD is a side from the small blue triangle. So right, small triangle. And DE is another side from the small triangle. Now that's all fine. We can have small over small. The only thing that we need to make sure of is that the other side is big over big, and that the side from big triangle here corresponds to the side from small triangle here, and that the side from big triangle here corresponds to the side from small triangle over here. So AD is right here. So AD corresponds to AB. So AB should be here. DE is here. That does correspond to BC. But since AD is not correctly put with its corresponding side, this proportion is not correct. So it will not always be true. So I'm going to get rid of that one. So let me put a mark through it. Let's take a look at the next one. So AD is once again a side from small triangle. And DE is another side from small triangle once again. So we talked about how AD should correspond to AB, and that is its corresponding side from big triangle. So these are grouped together well. DE should correspond to BC, and BC should be from big triangle. And let's take a look. DE and BC do correspond, and BC is from big triangle. So far it's looking like answer choice 2 is going to be correct. So I'm going to circle it for now, and I can always change it later on. Let's take a look through the other two choices. AB, and I'll just write B for big, is aside from big triangle. And BC is aside from big triangle. So we know that AB corresponds to AD, so that should be grouped with it. Nope, it's not. That should be AD, so this does not correctly put corresponding parts together. And finally, one more choice to look at. AD is from small triangle. BC is from big triangle. So if this is small over big, they should be corresponding, and AD and BC don't correspond, so that's not going to work. The side from small triangle and the side from big triangle that's grouped with it need to be corresponding. So answer choice 2 is our correct answer here. Okay, let's take a look at question number 2. So we have two triangles drawn, triangle ABC and triangle DEF. AB is 9, BC is 15, DE is 6, and careful, I don't know these are right triangles. It might look like it from how the diagram's drawn, but we never trust diagrams, so don't assume that these are right triangles. So ED is 6, EF is 10, and angle B is congruent to angle E. So which statement is true? So first, I want to take a look. I know the side lanes, so let me check out the corresponding sides. So CB is 15, and CB is the second and third letters. So it should correspond to the second and third letters here, EF. So 15 over 10, I just want to see what the scale factor is. 15 over 10. I keep typing in all the wrong things into my calculator, and that's 1.5. I shouldn't even been needed to type that into my calculator. AB is the first two letters, so it should correspond to the first two letters D. So I'm going to also check out the scale factor of 9/6, and that once again is 1.5. So we do see that the corresponding sides are proportional and there is a congruent angle in between. So already I see that these triangles are similar by SAS, and then I have the correct answer. I just want to take a look at the other answer choices and talk about why they are not necessarily true. So in number one, we don't know any information about angle CAB and angle DEF's relationship. And they're not corresponding angles to each other. That's why we don't know anything about the relationship. If the triangles are similar, their corresponding angles are congruent. But angle CAB and angle DEF do not correspond. Angle CAB is the last, first, and second letters. So it should correspond to the last, first, and second letters, which is F, D, E. So this angle corresponds to this angle. So this is not right. Okay, let's take a look at the next answer choice. So AB is from big triangle. CB is also from big triangle. So this side should put the corresponding parts from small triangle together. So AB is the first two letters. That corresponds to DE. Nope, this is not right. And finally, the last answer choice, AB is from big triangle. DE is from small triangle. So they should correspond if they have big over small, because corresponding parts from the two triangles should be kept together. AB is the first two letters. It corresponds to DE, so that's all good. FE is from the small triangle, so that's not good. We can't have big over small and then small over big. That's not consistent. We have our correct answer choice is 3. And that one was pretty easy to get in the beginning in this example. I just wanted to go through the other answer choices so we could see why they weren't correct. Okay, so let's take a look over here. So since they don't give us both of the triangle names, I think we should definitely try to figure out which sides correspond. Here, the triangles are oriented the same way. I was going to suggest drawing them to face the same direction, but it appears that they are facing the same direction here. So let's mark the diagram. Angle C is congruent to angle OT. Okay, so these angles correspond to each other. Yeah, so I think we should redraw the triangles so that they are with their corresponding parts together, now that I know that these two angles correspond. So what I'm going to do is I'm just going to turn the small triangle upwards so that this angle is where this angle is in this triangle. So once they're oriented the same way, I'll be able to clearly see what the corresponding parts are. So I'm just going to imagine I'm taking this triangle and turning it up. So if I turn it up, so that it's facing the same way as this one, I know that the purpose of turning it up is for angle T to be in the same spot as angle C. Angle U will come to the top, and O will be over here. TU is 4, OU is 5, and OC is 7. So if OU is 5 and OC is 7, that means this whole side from big triangle is 12. And we're looking for the length of ST. So we're looking for the length of this side over here. And I'm also going to mark what we know about TU over here. We know that. So let's set up a proportion to find the missing side of big triangle that we need. So side SU, I'm going to label as. So if I'm setting up a proportion, I like to do small over big equals small over big. It's not the only way to set up a proportion. So I know that aside from small triangle is 5. So if I'm putting 5 in the numerator, I need the corresponding side to it from big triangle to be in the denominator. So OU, when we drew the triangles facing the same way, is on the right of the triangle. So that's going to correspond to the side that's to the right of the big triangle. And that's the side we're looking for. That's the side we don't know, so that's X. I'm going to take another side from small triangle. So the only other one I know, oh, I did 5 already. My bad. The only other side I know is 4. So let me put 4 as my numerator. And then when we redraw the triangles facing the same way with their corresponding parts in the correct order, this is on the left of the triangle, so it's going to correspond to the left side of the big triangle. And just to make it a little bit easier to see, I just took the big triangle and I just redrew it so that it was facing the same way as we oriented the small triangle. So U is at the top of the small triangle and angle T is over here at the bottom left. So I just took the big triangle and I just faced it upwards so that U was at the top of the big triangle and angle C was still at the bottom left. And as you can see, since 4 is on the left of the small triangle, when the big triangle is oriented the same way, it corresponds to the side that's on the left, which is the 12. And once we have the proportion, we can cross multiply and solve. So we have 60 is equal to 4x. So x is equal to 15. And remember, x represents the whole side of the big triangle. We need to take away 4 because we're just looking for st. So that would give us 11. So 11 would be the correct answer here that we're looking for. Okay. And number 4, the ratio of similarity of boy to girl is 1 to 2. So 1 to 2, boy is the small one, girl is the big one. So BO is from this one, and that's x plus 3. And GR is corresponding to it, and it's from this one, so that is 3x minus 1. So all I'm going to do now is cross multiply. And I'm going to solve. And x is 7. GR is 3x minus 1. And that's 20 as our answer. Okay, let's take a look at the next one. I think I'm going to have to zoom out a little bit so that way you can see it better. Let me pause the video and zoom out. So the hardest part about this question is understanding what the question's asking for. So let's read it together. The accompanying diagram shows a section of the city of Tacoma. High Road, State Street, and Main Street are parallel and 5 miles apart. So High Road, State Street, and Main Street are all parallel to each other. And as I can see marked in the diagram, they are 5 miles apart from each other. So that means in total, from High Road to Main Street, 5 plus 5 is 10. So I'm going to put that there, might be important. Ridge Road is perpendicular to the 3 parallel streets. So where is Ridge Road? Here we go. And it's perpendicular to all the streets. So we got some right angles here. We got some right triangles. Might be important as well. The distance between the intersection of Ridge Road and State Street. So here's Ridge Road and here's State Street. So where Ridge Road meets State Street, that's right over here, the intersection. And where the railroad tracks cross State Street. Okay, so here's where the railroad tracks cross State Street, because that's the railroad tracks and that's State Street. The intersection of Ridge Road, which is at the bottom, and State Street is right here, because that's where State Street and Ridge Road meet each other. And that's 12 miles from here to here. Okay. What is the distance between the intersection of Ridge Road and Main Street? So here's Ridge Road, and here's Main Street, and here's where they meet or intersect, and where the railroad tracks cross Main Street. So here's the railroad tracks, here's Main Street, and here's where they meet. So we're looking for this distance over here. Well, this is not bad because I know that we have similar triangles. we have a line in a triangle parallel to the base. So that means the triangle formed is similar to the original triangle. Also, we have AA. We have the right angles and the shared angle at the top. So no matter which way you wanted to look at it, we do have similar triangles. The small triangle here is similar to the whole big triangle. Okay, so let's think about what we know. We know that a side of small triangle is 5 miles, and we know that the corresponding side to it from big triangle is 10. So that's a scale factor of 2. So to get from the other side of small triangle to the corresponding side from big triangle, it's also a scale factor of 2. They're proportional. So 12 times 2 is 24. All done. Okay. In triangle CED, we have points A and B. AE is 3.75, AC is 5, EB is 4.5, and BD 6. Explain why AB is parallel to CD. Okay, so let's take a look. I have two triangles in my diagram. I have small triangle and I have the whole big triangle. So this side from the big triangle would be 5 plus 3.75, so that's 8.75. And this side from the big triangle would be 6 plus 4.5, that's 9.5. Let me find some scale factors here. So let's do side from big triangle over corresponding side to it from small triangle. And let's do side from big triangle over corresponding side to it from small triangle. Let me get my calculator out because they're decimals here. These are not nice numbers. 8.75 divided by 3.75. So that's like 2.333 repeating. Okay. Let's see if it's the same thing for 9.5 over 4.5. That's 2.1. So those are not proportional. So I'm going to have to throw that idea out. Oh, my bad. I can't add today. 6 plus 4 is 10. This is 10.5. Okay, let me try that again. 10.5 divided by 4.5. That's the same thing. That's 2.333 repeating. There we go. So that makes more sense. So the corresponding sides are proportional, and we have a congruent angle in between the shared angle that's in the small triangle and the big triangle at the same time. So the triangles are similar by SAS. And when triangles are similar, the corresponding angles are congruent. So in small triangle, this angle here is at the bottom left. So it corresponds to the angle at the bottom left here. And guess what? When we have corresponding angles that are congruent, that means the lines cut by the transversal are parallel. Just like if we can show that alternate interior angles are congruent, that can prove lines parallel. It's the same thing with corresponding angles. If you can show that corresponding angles are congruent, that actually also proves the lines parallel. I'm going to type up an explanation. So here I have my explanation typed up, and this would be a completely complete reason explanation. So it says since EI and EC and EB and ED are proportional by the same scale factor, and angle E is congruent to itself by reflexive, triangles AEB and CED are similar. Similar triangles have congruent corresponding angles. If corresponding angles are congruent, then lines cut by a transversal are parallel. I don't have the congruent symbol on my computer, so I was just using the equal signs. But my equal signs mean congruent. Okay. Here I already did the coordinate proof, so I just want to show you what I did. So what I did is I used the distance formula to find the length of EF and EH. And when I got the lengths, I divided big triangle over small triangle to get the scale factor. And I found the length of EG and EJ. And I did the same thing, big triangle over small triangle to get the scale factor. And I noticed that they were the same. And the proportional sides also share an angle in between. So that's angle E congruent to itself by reflective property. And that proves the triangles are similar by SAS. So I have this written up over here in an explanation, so you can pause the video and read the explanation. And whenever you're writing a coordinate geometry proof, you do need to have a concluding statement summarizing what your calculations show. If you don't have a concluding statement, you don't get full credit. That's on the Regents exam as well. Okay, let's take a look over here. So we're proving a product, and in order to prove this product, did I miss something? Let me just check. I don't know if I missed anything. Yeah, I missed something. I missed a lot of things. Okay. Question number 8. Okay, I was skipping to question 10. Okay, so I'm just gonna do this algebraically. It'll be like 2 seconds. Ratio of 1 to 5. That means the fraction I'm gonna be multiplying by is 1/6 because there's 6 parts in total. 1 plus 5 is 6. And we always use the number on the left of the ratio as the numerator. Directed line segment, starting point, ending point. So starting and ending. And I already determined what my fraction is gonna be. So I'm going to find the x coordinate first. So change in x, that is 6 minus -6, so that's 12. Multiply that by the fraction, so that's 2. And then add the starting x coordinate, and that would be -4. Okay, same thing for the y coordinates. So I'm going to do 7 minus -2. That's the change in y, and that gives me 9. I'm going to multiply by the fraction. Oh, that doesn't work out too nicely. What's 9/6? 1.5. That's not as bad as it could be. And then add my starting y coordinate. So my y coordinate of my start point is -2. 1.5 plus -2 is -0.5 or -0.5. So we have -4, -0.5. And that is the point that divides the line segment in the ratio of 1/6. This is an example where graphically, you would be able to do it because it does work out to be exactly halfway in between the grid points. So you can do that exactly, but it shows that like it might be hard to do this graphically, especially if the numbers don't work out nicely, if you get decimals that aren't 0.5. So the algebraic method is easiest for me. It takes 2 seconds, as you just saw. Next one, the proof. Okay, oh, this is the harder. Let's take a look. So we're proving a product. EH is right here. CH is right here. FH, oh, that's attached to CH, so I want to use the same color. So this is one of my focus triangles. And AH, that's right here. So this is one of my focus triangles. So now I know the triangles that I'm going to be proving similar. Let's see what we're going to do here. So I already know the vertical angles formed by my intersecting lines. I already have one pair of congruent angles for AA from the vertical angles. They are telling us that EF is parallel to AD and that EF is also parallel to BC. And AD is congruent to BC. So if AD is parallel to EF, and if EF is also parallel to BC, then that means that AD has to be parallel to BC. And that's not by the transitive property, because transitive property is congruent things. So we have something special for parallel lines, and we call that transitive property of parallelism. If something is parallel, if a line is parallel to another line, and that other line is also parallel to a third line, that means these two lines have to be parallel to each other because they're both parallel to line EF. So if they're both parallel to line EF, they have to be parallel to each other. And that's the transitive property of parallelism. So we know that AD is parallel to BC. And we know that AD is also congruent to BC. Now, if I have a quadrilateral that has one pair of opposite sides that is both congruent and parallel, what kind of quadrilateral is it? The answer is a parallelogram. So now I know that we have a parallelogram. And if we have a parallelogram, well, that means AB is parallel to DC because opposite sides of a parallelogram are parallel. And then I have my congruent alternate interior angles. If you're having trouble seeing the alternate interior angles, here I have parallel lines cut by a transversal. So I'm just going to highlight them. And then you can see that backwards letter Z. And in the corners of the Z are those congruent alternate interior angles. So now we have AA. And after that, we just need to prove the proportion and then prove the product. So remember the easy trick for coming up with the proportion to get the product that you want? Take the first term and divide it by the very last term. Take the first term on this side of the equal sign and divide it by the last term on this side. And then notice that when you cross multiply, you get EH times CH, which is what you want here. And when you cross multiply the other way, you get AH times FH, which is exactly what you want here. I'm going to pause the video and I'm going to write up the proof, and you should do the same. So please pause the video so that way you can try writing it up yourself. So here is the full written up proof for the proof in number 9. So from the givens, we see that AD is parallel to BC, and that's from the transitive property of parallelism. Once again, that's because AD and BC are both parallel to the same line EF, so that means they have to be parallel to each other. So once we know that AD and BC are parallel, and from the givens they're also congruent, we know that ABCD is a parallelogram because a quadrilateral that has one pair of opposite sides that is both congruent and parallel is a parallelogram. And now that we know that ABCD is a parallelogram, we know that the other set of opposite sides, AB and DC, are also parallel because opposite sides of a parallelogram are parallel. And from there, we can say that the alternate interior angles are congruent because we have parallel lines cut by a transversal. And we also have our congruent vertical angles formed by the intersecting lines. We have that letter X. And oops, I forgot this step. So before I can prove the proportion, I do need to state that the two triangles are similar to each other. So let me stick that in. I'm going to call that step 6.5. I can't believe I forgot to write that step in. So the statement would be triangle AEH is similar to triangle, CFH. And my reason for that would be AA. Now that I know the triangles are similar by AA, it's one more step after that to prove a proportion. And we talked about at the start of this proof how to figure out the proportion that will cross multiply to get you the product. And it's always the same reason for proving a proportion. Similar triangles have proportional corresponding sides. And then after that, it's one more step to prove the product that we want. And to prove a product, it's always the same reason. In a proportion, the product of the means equals the product of the extremes. Okay, one more proof to go. And this proof is a little bit easier than the last one. So we only have two triangles in the diagram. So those are the two triangles that we're going to be proving similar. And already I see vertical angles. And we know that ABCD is a parallelogram, so that might be helpful to us. So since we have a parallelogram, we know that the opposite sides are parallel, and then we have parallel lines cut by a transversal. We could see that letter Z. So what we have are congruent alternate interior angles. And now we know the triangles are similar by AA. We talked about how to get the proportion from the product. Take the first term, divide it by the very last term. Take the first term here and divide it by the last term here. And that cross multiplies to give you the product you want. So I'm just going to take a second and write the proof. Please do so as well. Here's the proof written up. So as you can see, everything that we talked about is here in the proof. So we have opposite sides of the parallelogram are parallel. So then we have the congruent alternate interior angles, the vertical angles, and that gives us AA to prove the triangle similar. After we prove the triangle similar, it's one more step to prove a proportion, and it's always the same reason. Similar triangles have proportional corresponding sides. And then after that, it's one more step to prove the product that we want to prove. And it's always the same reason for that every time. In the proportion, the product of the means equals the product of the extremes.